Good morning everyone, how are you all? So today we are going to discuss about a very important topic of your chapter, dual nature of radiation. So today we are going to discuss about photoelectric effect. This topic is very important. In this topic we will discuss about Lenard's experiment on photoelectric effect. So before beginning of this particular topic, let's recap what we did in the previous video. So in the previous video we discussed about the basic concept of electric emission from a metal surface, right? In that particular topic we discussed how many types of electron emission can be possible, right? We talked about work function, that the energy required to emit the electron from the metal surface. So that is known as work function, right? Apart from that, we discussed about the types of electron emission, like we discussed about your thermionic emission, in which the filament raised to a temperature of 2500 Kelvin to your 3000 Kelvin, and it emits the electron. Then we discussed about field emission, in which the metal surface is kept in between of the two plates, where the electric field is induced up to the value of 10 to the power 8 volt per meter, and they emit the electron. Then we discussed about photoelectric emission, in which a particular threshold frequency light is incident on the metal surface and it emits the electron. Now that photoelectric emission phenomena we will discuss in elaborate way in the topic, that is photoelectric effect. This is the explanatory version of photoelectric emission. And on this particular topic, Lenard was a scientist who did an experiment to prove that for a particular threshold frequency, when incident on a metal surface, it can emit the electron. Like in previous video we discussed, like zinc, aluminium, magnesium, they have a ultraviolet region of frequency of light. When it incident, then they emit the electron. Same we discussed about alkali metals, that visible region light is, if incident on that, then they will emit the electrons. So in this topic we will discuss Lenard experiment in detail, in which first we discussed about the introduction of photoelectric effect. Photoelectric effect introduction, you already know that when a particular threshold frequency ray of light incident on the metal surface or a photosensitive metal surface, then it emits the electron. So that particular phenomena, that effect is known as photoelectric effect, right? Experimental setup, if we talk about, so this is the experimental setup of Lenard. Okay, in this experimental setup he has taken a closed chamber. One closed chamber was taken by him, and in that closed chamber he left out one window for light to enter and fall onto the metal surface. In that closed chamber he made a window through which the light can enter and fall onto the metal surface. That particular window he named as quartz window, right? Quartz window is the window through which the light of particular frequency is coming, and it is incident on the metal surface, right? Now two plates he have taken. He took two plates. One was photosensitive plate, that is S, denoted as S for sensitive, and one is C for collector plates. The work of the collector plate is to collect the electrons which emit out of that particular sensitive plate. So it collects the electrons which emit out from the surface. He took one AC source. With the help of AC source, he established the electric field between these two plates, And if electric field is established, then you know E equals to F upon Q, and F is equals to EQ. The charge is E, so F is equals to. So if electric field is there, then electrons will experience a force inside that electric field, and which will help to move the electrons from one plate to another plate. So that is why he used one AC source, right, in order to establish the electric field between these two plates. And by the establishment of electric field, force will be experienced by electrons, which help them to move from here to here with the help of this connecting wire. We use this connecting wire for the movement of electrons. Connecting wire for the movement of electrons, right? So this AC source, this side it is plus, and this side it is negative. And a microammeter he took in order to, when electrons will pass through, so there will be a deflection in the microammeter, and we can find out the current, that the current starts flowing when the electrons will flow through the connecting wire. That will be measured with the help of microammeter. Clear? So this is the experimental setup of Lenard. Okay, so first we discussed about introduction of photoelectric effect, you know, then experimental setup, right? So third is your working of this particular setup. Now you know already, as soon as the light of particular frequency incident on the surface of the metal, the electrons start emitting. Okay, this is the first thing, that as soon as the light will fall, but जब तक light जो है उस particular threshold frequency को reach नहीं करेगी, तब तक electron emit नहीं होंगे. Getting my point? So a particular threshold frequency is required to emit the electrons. Now electrons have been emitted and AC source is on, so this side of the plate is positive and this side of the plate is negative because of this negative, and positive because of this positive. So an electric field will establish from here to here, from positive to negative. This will be the electric field. Electric field will establish from positive to negative. You already know in the first chapter you must have studied. So electric field will establish from positive to negative. Now as soon as the electric field will establish, force will be experienced by the electrons in the opposite direction of the electric field, because they are negatively charged. Positive charge experience in the direction of electric field, negative charge experience the force in the opposite direction of electric field. So as soon as the electric field will establish, the electrons will experience the force in the opposite direction. So force will be experienced in this direction. Correct? So they start moving towards the collector plate. Okay, they start moving towards the collector plate and they accumulate over here. Right? As soon as the accumulation of electron starts, so the movement of electron start outward circuit, and electron moves from this side to this side, and the micrometer shows the reading, and the current starts flowing. And the particular current which flows by this phenomena of photoelectric effect is known as photoelectric current. That is known as photoelectric current. And these electrons are known as photoelectrons. They are called photoelectrons. They are called photoelectrons because they emit because of the light, and photo relates with light. So electrons, emission of electrons because of light are known as photoelectrons, and the current flows because of these photoelectrons is known as photoelectric current. So first is your generation of photoelectric current. So this is how the photoelectric current generates. Now this is a metal surface, you know. It has a limited number of photoelectrons, free electrons which can be emitted out. It is not possible that a particular metal surface contain n number of electrons to flow. They have a limited supply of electrons. So what will happen as soon as the AC source increases in positive? Like for example, initially at 10 volt, it is giving 10 microampere. At 20 volt, it is 20 microampere. At 30 volt, it is 30 microampere. At 40 volt, it is 30 microampere. At 50 volt, it is 30 microampere. Now you can see why there is increase in the current, because as soon as the light will be falling and we will be increasing the voltage, so more and more number of electrons will emit out. More and more number of electrons will emit out. So more and more number of electrons will circulate in the circuit. So that will increase the current, photoelectric current. But a time will come when the total number of free electrons they emit out from the metal surface, and the photoelectric current becomes a constant. Right? It is not possible that the photoelectric current keeps on increasing. It is not possible because there is a limitation with the metal surface also. So metal surface emits out the electrons it contains as a free electron. उतने ही वो इलेक्ट्रॉन emit कर सकता है जितने उसके पास है, उससे ज्यादा वो emit नहीं कर सकता. तो एक बार अगर वो लिमिट रीच हो जाती है, पहुंच जाती है, तो क्या होगा? फोटोइलेक्ट्रिक करंट क्या हो जाएगा? कांस्टेंट बन जाएगा. ठीक है? सो फोटोइलेक्ट्रिक करंट becomes constant after a certain value. Okay, so photoelectric current is not such that it keeps on increasing because it depends upon the photoelectrons. When the number of photoelectrons are fixed in a metal surface, so at a certain time the photoelectric current will also become constant. So after some time, as we increase the positive potential, so what will happen? Initially there will be increase in the photoelectric current, but at some time, after some certain voltage or potential, what will happen? The photoelectric current becomes constant. You can see. Okay, so this was first thing. He experienced that the photoelectric current becomes constant after a fixed value of potential. Then what Lenard did, he changed the polarity. Now when he changed the polarity, this side of this AC source becomes negative and this side becomes positive. So this side becomes positive and this side becomes negative. Now the direction of electric field will also change. Earlier it was this direction, now it will be in this direction. The electric field will be in this direction now. Okay, so what will happen? This side is negative, electrons are also negative, they will start feeling a repulsive force. They will start feeling a repulsive force. Now the question arises that does the photoelectric current instantly become zero as we change the polarity? क्या फोटोइलेक्ट्रिक करंट तुरंत 0 माइक्रोएम्पियर हो जाएगा कि जैसे हमने पोलैरिटी चेंज करी और इट स्टॉप्स? नो. ओके, देयर इज अ ग्रेजुअल डिक्रीज इन द photoelectric current because they are experiencing a force from due to negative charge towards positive charge. Some of the electrons may be having certain energy. कुछ के पास इतनी एनर्जी होगी कि वो इनिशियल नेगेटिव पोटेंशियल को क्या कर दे? ओवरकम कर दे. तो फॉर एग्जांपल लाइक इट वाज सीन थ्रू एक्सपेरिमेंट, it was seen that when the voltage in negative was 10 volt the potential was 30 microampere. Okay, when minus 20 volt, it is 20 microampere. When it is minus 30 volt, it was 10 microampere. And when it was minus 40 volt, it was 0 microampere. Through experiment, it was observed that there is gradual decrease. There was gradual decrease in the photoelectric current when we change the polarity or a negative potential is applied. Okay, so when it was observed and a case came when the photoelectric current becomes 0. So that particular potential was termed as stopping potential. This is a very important term. That particular potential was termed as stopping potential. Stopping potential is the potential in negative when applied to a plate when and the photoelectric current becomes 0. So that particular potential is known as stopping potential. This is a very important term. Stopping potential. Define stopping potential. Many times it usually asked in the examination. So how you will define stopping potential? Stopping potential is a negative potential when the photoelectric current becomes 0. Right? So that this is a concept of stopping potential. So he calculated the concept of stopping potential also, and he observed that the energy of the electrons at this stopping potential is maximum. He concluded that from this particular concept, that we will also see through graphs also, that the energy is maximum at this stopping potential of the electrons. He concluded from this, right? So he gave an expression also. He said that we are doing some work in terms of Q into V. We have already studied this. Q into V. Now work done is same as energy. So energy is maximum. So half mv square max is equals to electronic charge and V naught. So V naught is your stopping potential. Getting my point? This expression is very important. Okay, so on this expression, usually numericals are also asked. So do this expression very clearly. So this is all about your photoelectric effect. Okay, so in that particular effect, we discussed about Lennard experiment, experimental setup. We discussed how the current generate, how the current value becomes constant and how the current value becomes 0. And at 0, the potential applied to the experimental setup is known as stopping potential. And the energy at the in the stopping potential required by the electrons is maximum. So next we will discuss about the graph representation of stopping potential with different terms like intensity, potential, and those graphs are very important. So just go through this. It is very important topic. If you have any doubt, please do comment. I will resolve your queries. That's all. Thank you.